So let's start with the solar system. Let's be polite. Right to the end, so I have fond memories of you. Okay, let's start with the solar system. Notice that this solar system, by the way, you cannot draw a picture of the solar system. So in this one, they've actually drawn the size of the planets much too large. You'll see that later today we're going to make a real scale model, and the point of the scale model is that you can't see the solar system. These things are just really, really small. But if we could see them, the inner planets would be really, really close to the sun. Then there's like the asteroid belt. Then there's the outer planets, which are the gas giants. And then notice that Pluto's orbit is sort of at some funny angle like that, right? And I know there's this rumor that it got demoted from being a planet and that it's no longer a planet. But I say people who believe that are communists. I believe that those people hate America. And the reason for that is that Pluto is the only planet of them that was discovered by Americans. So I really feel this is like a discriminatory sort of thing. Okay, this is the best way.
The mnemonic device doesn't work.
Right, right.
That's damn important.
Right.
How the hell are you supposed to know the word without the mnemonic device?
Okay. Anyway, here's my favorite mnemonic device. Is my very elegant mother just sat upon 9 porcupines. I know that there's like just ordered us 9 pizzas, but sitting upon 9 porcupines is a better mental image, isn't it? Isn't that? I don't know. I'm picturing this woman, with. It's always a calico dress and like earrings and stuff like that. She's very elegant. And she's sitting on 9 porcupines. But there it is. Right? And then the planets themselves, the inner planets, and these guys are really quite close together, close to the sun and close to each other, relatively speaking. You'll see that when you get outside. Okay, are these guys? And this is sort of the size of their size relative to each other. So Earth is the largest one. It's got enough gravity to keep its atmosphere. Right, Mars, not enough gravity, it's too small. It's like, 0.6 times the mass of Earth or something like that, right? So it doesn't even, basically nitrogen has escape velocity. It's going fast enough in the upper atmosphere to escape from Mars, right? And then Venus has got the opposite problem. It's got like not too much gravity, but too much atmosphere right now, right? Mercury is very much like the moon. It's a very moon-like planet. No atmosphere, but what does it have, like ionized particles? Basically just, its atmosphere is just stuff that's been blasted recently off the surface by the sun, right? And then the asteroids, what they think was that there was actually a planet, right? And that somebody like Sarah Palin was elected on that planet president, right? And that destabilized the Republican Party, which caused, basically, it was like a house of cards. It all just crashed down. And I usually just pick somebody, it's like, it was George Bush for a while, but, there we have it, right? And then you go to these guys are bigger, right? Jupiter is so big. Jupiter is so big that hydrogen. See, the thing about a gas is that little particles go faster than big particles. Do you know that? Do they know that from ideal gas law in chemistry? And you showed them that little. Did you show them that little shaky thing? There you go. You showed them the shaky thing, and the shaky thing. And did you put like different size particles in there?
Yep.
Yeah. And when you do that, the little ones are going fast, and the big ones are going more stately. But they have the same average kinetic energy because
it's the mosh pit there.
Yeah, right?
You got giant sweaty dude with the overalls, kind of lumbers along.
Mosh pit.
Then you got little skinny, scrawny on meth dude.
Yes.
Like running around.
See, these are analogies that But the point is,
girl in the corner going like wearing the Birkenstocks. She goes the same speed no matter what.
That's right. Doesn't matter, yeah. Because she's not listening to the music. She's got her own music in her head, right?
Little ones go fast. They know this.
So with the deal with Jupiter, the deal with Jupiter is that Jupiter has enough gravity to actually hold hydrogen in. It's a gas giant. It's got a lot of hydrogen on it, right? Earth, by the way, Earth is too small to keep hydrogen. Hydrogen has escape velocity. You do not find hydrogen in the Earth's atmosphere except in like maybe trace amounts. Helium, the same thing, right? That's crazy. Yeah? So Jupiter is actually getting heavier and heavier. It's sucking hydrogen from intergalactic space. It's not a huge thing, but there it is. So there they are, and then I just say Uranus, and I don't make jokes about that. So there it is. They did find rings around Uranus with a NASA probe. So, oh, come on, you guys.
It's true.
Right. And then you just keep going out, and it's the Kuiper Belt, is it? Yeah. And the cloud. You have to actually inhale to say that. Let's all say that. Cloud, right? Right? This thing is way the heck and gone. It's 50,000 astronomical units in radius. So it's 50 times farther from the sun than we are, right? That's what that means, right? So it's way the heck out there. I know that the Voyager probe has left the solar system, but I don't think it's gotten here. You know, it's just left. It's gone beyond Pluto, right? Is what they said, right? Okay. And then, you know, the total mass out there is 10 to 100 times Earth's mass, so that's not a lot. The Earth is not a very massive object in the solar system. If it was 10 to 100 times Jupiter's mass, then that would be something, but, right? There might be another planet there. You know, they keep looking, basically they look at the motion of the inner planets, and you can look at their motion. If it's not perfectly predicted by the other 8 planets that we know about, right, then there could be something else out there that's influencing them. So, yeah, there could be that 10th planet or the 9th planet if you're a communist. Okay, and then this is a picture of a comet. Okay, and there we go. Right, and then, you know, did anybody take astronomy? There we go. So what's the deal about the tail of a comet? Does it point behind the comet or does it point away from the sun? Do you remember? Yeah, it points away from the sun, doesn't it? Yeah. So this comet could actually be going to the right. All we know though is that the sun's probably likely over here. Right? And this stuff here is being blasted off by the solar radiation from the sun, charged particles, photons, stuff like that, solar wind, right? Okay, so that's kind of crazy. And then there's 2 tails. One is an ion trail. I think that's the one that glows, and one's the dust trail. What's the deal with those? Do you remember? Because I'm actually asking. I'm a bad astronomer. We'll have to ask Youngberg. Let's just kidnap him, bring him in here. Tell us. Come on, circus boy. Okay, so Pluto is probably a Kuiper Belt object that got trapped by the gravity of the inner planets. Right? Notice that its radius, its plane of orbit is not the same as the other ones, right? All the other planets are pretty much on the same plane. This one's like off kilter, so it's probably not an original one. So that would be the best argument for making it not an original planet, if you were such a communist person as to do that, right? Would be that it's not certainly not a charter member, right? Here's a funny story though. We're going to later do a human model of the solar system and line up in front of the school. And I did that when I taught at the Indian school, like Native American school. We did that over 2 city blocks. And nobody had the ambition to be Neptune, much less Pluto. I think we just couldn't get a Pluto, right? So I went down there and I was Neptune, and I'm standing out there in Neptune. And I looked in at one of the inner planets, and I couldn't tell which one it was, lit up a cigarette in class. Just like I see smoke, it's like, right? And they were so close together that I couldn't tell which child it was, right? And what they said was that they were so close to the sun that they were actually ignited by the sun's heat. Was the thing.
My guess was Venus.
Yeah, it could have been Venus. You know, it was, and it wouldn't have been like any real big crime, because like at the Indian school they had like a pipe ceremony every day, and like you took a puff of tobacco. Like I took a puff of tobacco every day for a year. And you know I craved tobacco. I started buying cigarettes and like cigars. Right? It's so addictive. Don't even try it. Because it's not bad like they tell you. It's good. Okay? But you're going to like die of cancer, right? No, seriously, if you just try it, like just 1 puff a day, I was like slipping into addiction. That's scary. So let's zoom out. Here's the sun right there. Notice there's a line going up to the center. So there's the sun. Here are the nearby stars. All of these stars, the sun and you and me and all the stars that you can see are moving at 1,000,000 miles a day in an outer spiral arm at 40,000 miles per hour in a galaxy we call the Milky Way. I've heard that song a few times, yes? Okay. So all the stars you can see in the sky, if you're looking at a star and going, there's a star, there's a star, there's a star, or even if there's like a big band of stars, those are all Milky Way objects. They're all in our own galaxy. And Alpha Centauri, Proxima Centauri is the closest one or something like that, right? Sirius is a seriously bright star. And I don't have any other jokes, you know. But there it is. So these things, notice that these guys, the big bright stars are within, say, 20 light years, 100 light years, 500 light years. The North Star is 600 and some light years from us. Okay, just to give you some idea. And then these are galaxies, and these are Hubble types. So this is kind of like botany. Elliptical galaxies are galaxies that are, if you saw them from any direction, they would just be, basically it's like remember that beehive swarm?